Hi everyone! So today we are going to start chapter 6, which is called polynomial functions. And you have looked at polynomial functions before, but it's probably been a while. So here are 3 examples of polynomial functions. And they certainly can look very different than this. This is just kind of a little example. So here's first a linear function, which is just a straight line kind of going in any direction. This one's called a quadratic, which has an exponent of 2 as its biggest part here, and it has this beautiful kind of U shape. And then this one that's probably new to you, it's called a cubic, and it has a exponent 3 as its biggest exponent. There are certainly more, like the next one would be have an exponent 4, but we're going to stop with these 3 because it gets pretty repetitive after that point. So we'll just focus on those 3. What we're going to do is we are going to learn some things about them, and we're going to learn how to use your calculator to find things. So if you have taken pre-cal, you'll see that we cover a lot of the same topic kind of from a different perspective, and we'll use your graphing calculator to help figure some stuff out. So it might be a little repetitive for you, but you'll see that there's still some stuff to learn from the applied perspective. Okay. Let's start off with some definitions. Today we are just going to work on some basic graphing ideas and basic graphing calculator tools. So let's start off with this. I'm jumping around in this unit. I'm going to start off with 6.3. I just find it works better for whatever reason. A line of best fit. You might have last heard this in a science classroom. But a line of best fit is a line that closely matches your data as best as you can. So a line that matches the data. I'll leave myself a little space because I'm going to draw a picture. The data as closely as possible. In your graphing calculators, oh, that's nice and fuzzy. In your graphing calculators, they call it a regression equation. So we'll just put that in little quotation marks over here, regression equation. So on a test or on your exam or something, I might say, find the regression equation, and what I mean is line of best fit. So let's say you were studying something and you made yourself a graph to kind of look at whatever it is you're talking about, and you found all these little data points, and you probably had to do this in a lab for science at one point. Well, these data points are great, but it doesn't really help you make choices about the future, make guesses as to what the future would be, or guesses to what a specific value would be. So line of best fit is kind of like the graphical version of an average. It's usually, in this case, this would be a linear function. It'd be a straight line. If it matched a quadratic, it'd be a beautifully curved quadratic. Like it matches the shape of the graph nicely. And then the line of best fit is between, kind of like average all those points out as best as possible. It's going through as many points as possible, and it's right in the middle of many points as possible. So it's just a nice average. Okay, so we're going to use that a lot in the next couple days. After we do this unit, we'll then do a unit on exponentials and logarithms. And we are going to use this again, and then we'll do sinusoidal regressions, and we'll do that again. So we're going to use this so many times, it'll be second nature. Okay, let's start off with linear functions today. A linear function looks like this, a linear equation looks like this. Y equals mx plus b. That is old hat at this point. You've heard that a lot. Let's remind ourselves of a couple things. First, m is the slope. So that says like how diagonal is this thing? Does it have a really steep slope, or a very flat slope, or maybe even a negative slope? Reminder, it's rise over run. Now this is really just background information. We're not going to use it too explicitly ourselves, but it's good to know. The b is the y-intercept. Too lazy to write out the whole word. And the y-intercept is always a really important point, especially as we look at specific situations. So if this was my like experimental data, where it crosses the y-axis over here might be a really important point, because that might be like my starting point. So Y-intercept is where does the line cross the y-axis. And hopefully that's just a reminder as well. Hopefully you've already known that, but maybe you haven't thought about it in a while. All right, so that's usually a really important point. And oh good, my dog has spotted someone outside. All right, let's start off by looking at a situation and making a graph of this. And this is just going to be a purely paper pen task right here. We're not going to use our calculators for this one. And there often is a question just like this on your final exam, and it's usually worth 3 points. So it's a really achievable 3 points, 3 marks to work through this, but it does take a little bit of attention to detail. So let's take a look at this totally made up question by myself. Penny, the dog that's currently barking over there, measured the number of hairs she loses on each given day below her findings. So day 1, she has lost 16 hairs today. By the end of day 2, she has lost 21 hairs in total. 3, 35, yada yada. Obviously it's going up, she's losing more hair every day. Let's try and make ourselves a graph of this. Alrighty, so first things first, we need to figure out what goes where in terms of on this graph. Now, if you ever have time is always an independent variable. Alrighty, the puppies are trying to play. Okay, so if you ever have time, that is always an independent variable and will always go on the x-axis. So days is a version of time that will always go on our independent. So I usually try to think of like which part comes first in what you're talking about, or which part is the part that is going to kind of truck along without you regardless of your experiment. So time is going to move along without me regardless if I'm doing this experiment or not, and it kind of dictates the pace of things. So that's my independent variable. I just like having the lines there. I don't know if you can really even see it, but I think it makes it look nicer. So I'm going to label days down here. And then on the y-axis, I guess that means total number of hairs lost. Great. I should really capitalize these, but I kind of made it too messy. Total number of hairs lost. So these two labels are super duper important, and if you have 2 good labels, you don't really need a title. If you love having a title because your science teachers have drilled that in, throw one in there. But for us, these ones are just good enough. Now let's put in a scale. So looking at my table, and I usually go back to my table because that gives me all my information. Let's try and think of how big this scale needs to be. Well, I think I'm going to start at 0 days because that's pretty reasonable. Start at 0 days, and we definitely need to get up to 6 at least. So if we go a little bit bigger than 6, like let's say we get to 7 or 8, great. But I want to be able to fill out the whole scale. So I don't want to get up to like 6 right here and then not use the rest of this whole graph, because that's not really a beautiful graph. We want to fill up the space as much as we can. So I'm going to give this a quick count. I counted like 21. So I figure that if I start at 0 right here, and if I take 3 boxes to do 1, I think this will work out pretty nicely. And you can always use a pencil, unlike what I'm doing right now, and see if it works out nice, and if not, erase and try again. It's pretty difficult when you're doing this with pen to erase and try again, so I sincerely suggest you use a pencil and then kind of go from there. Alright, so that one worked out really nice because we got up to like 7. That's perfect. On this scale, I don't think it works out as nicely, but I'm going to go up 2 boxes for 10. And I didn't really look at this before I started, but I'd like to start at 0 hairs lost, and I definitely want to get up to at least 50. So I'm at 50 right now. I'm just going to throw a 60 on there so we get up to 52. And I didn't do that great of a job of using my whole space, but it's not terrible. The number one thing I need you to work on is that these numbers have to be consistent with how many boxes you're using. So if you use 3 boxes for 1, You have to always use 3 boxes going up by 1. You can't say 1, 3, 5, 7. You can't do that. You have to, if it's 3 boxes for 1 day, it has to always be 3 boxes for 1 day. I find that's like the number one mistake that people make. So far, we could actually get like 2 out of 3 marks on this because we have a beautiful label, we have a beautiful scale that's a reasonable scale. We kind of need to finish it off, and then we need to draw a line of best fit. So let's put all these dots on our graph. So my first dot, day 1, 16. So day 1, there's 10, there's 15. I'm going to go a little bit above 15, throw a dot right there on 16. Now this doesn't have to be perfect because we're kind of guesstimating exactly where 16 is, but it should be pretty close, and I should be able to guess which dot we're talking about. It should definitely be in the right box area, the tiny little box. Like it should be in that right space. So let's throw a few more dots on here. Definitely works out nice when it's right on the graph, right on the lines. Okay, beautiful. I have a bunch of dots. It did ask me for a line of best fit. It won't necessarily always, but this time it does. So I usually kind of make my ruler like this so I can see it right down the line there. And I try to put as many dots on the line as I can. And then you try to put as many dots on, like keep it even. How many dots are on below the line? How many dots are above? It certainly doesn't have to be perfect. It's okay if it's not. And then the last thing we need to think about are arrows on this. Are we going to have more days past 6? I mean, I hope so, because I'd be devastated if my dog died. So I'm going to put an arrow over here. That's super reasonable to have more time after 6 days. I hope. This way, I didn't quite go to the y-axis here, but I'm going to. Should I put an arrow going towards -1 day? No. We can't have negative time, so I should never really put a negative into time. There will be other situations where this isn't time, and maybe it will make sense, but I don't think in days, negative time, that makes sense as a thing. So we're not going to throw an arrow that way. Now let's just make a quick list of what graphs need. Just a reminder, this might be good information for a study sheet. Graphs need axis titles. So total number of hairs lost and days, that has to be there if we're going to get full marks on this. 2, we need scales on X and Y axes. The 1, 2, 3, 4, 5, 6 here. They have to be consistent. Question I get sometimes is, does this scale have to match that scale? No, they can be totally different. Like here I use 3 boxes for 1, and here I use 2 boxes for 10. Totally separate, that's okay. It's more of a time constraint than anything else, right? But just this one has to be consistent, and that one has to be consistent. And then you need to have some dots. Dots on your points. That's all the dots we put there. Sometimes, and it depends, you might need a line of best fit. This time it asked it for it, so I definitely put one on there. Kind of depends on the situation. And you might need arrows on that. Oops, arrows. So that one depends as well. You have to kind of read the situation. Notice I used 1 arrow, I didn't use 2. So it depended on the actual question that it gave me. Alright, let's flip the page, and we're going to use the exact same example, but we're going to start to use your calculator. So that's super fun. Here is a page that I tried to set up with just information for you. So this is a really good place to come back to what you might need for the future. This is kind of like how to set up your calculator a little bit. So here's my calculator. I had some old stuff in there. And what we're going to do is we are going to do some things that we're going to have to do once that we aren't really going to have to work on again. So, so this step right here, we won't have to do every time. So let's start off up here. First, we need to enter the data points. So if I want to make a graph in my calculator, I have to tell my calculator what the data set is. They don't know how many hairs Penny's lost every day. So that's our starting point right here. So I'm going to find this button called Stat right down here. Stat, let's hit that one. And we're actually going to come here a lot of times. And if you took grade 11 applied, you would have seen this quite a few times when you were doing statistics. We're going to say number 1 for edit. And it brings you to this thing to make lists. So mine currently has stuff in it, and maybe yours does if someone else was using your calculator. And I'd like to clear it all real quick because, you know, I don't want to have these lists in there. So I go to the top, hit clear, and enter, and it clears the whole thing. And then I'm going to do that to that one here too, just to empty it all out. We don't need to reformat your calculator every time or reset your calculator every time to get rid of that. Sometimes you don't start with L1, L2, L3. If for some reason you're missing like an L2, there is a way to work on that. So do you see right above window it says table set? So I'm going to go blue button, window, and you'll notice that this is kind of my setup. So here is what I have, and yours might look a tiny bit different, but it should be okay. Table start, delta table 1. That's what we should have in there to make this work okay. And if you have problems, let me know and I'll help you figure it out. Okay, so here I have a place to put in my data, and you'll actually notice there's a bunch of columns. There's 6 of them in here, which is great, super helpful. I really only need 1 and 2, and we're going to put the X values into L1 and the Y values into L2. So I'm going to put in the data for Penny's hair. Day 1, 2, 3, 4, 5, 6. And then in L2, the number of hairs that she lost in total. Beautiful. So now I have this beautiful little table. Great. Now let's do some things that we won't necessarily do every time. So we have to create a scatter plot where we're going to change some settings. So this is some settings that I need you to be able to get to on a regular basis because we are going to play with them a little bit. Do you see right above y equals here, it says stat plot? I'd like to take a look at stat plot there. So I'm going to go blue stat plot, and we're going to enter number 1 here, so just by hitting enter. And then we have a setup like this. So just to guide you through it here, I'm looking at plot 1, that's what I'm working on. It's highlighted, as in that's the one that is currently what I'm working on. Mine is currently off, so I'm going to turn it on by going to on, so it's blinking on there, and hitting enter. And now it's highlighted, which is great. Last, you might have used a histogram, but today we're going to use a scatter plot. So mine is currently highlighted on the scatter plot, which is perfect. I want this to say list 1 and list 2, and if yours doesn't say that, you'll notice down here for number 1, like the one that we use all the time, there's a little L1 above it, and mine's in blue, so I would hit the blue button and then L1, and that puts in L1 for me, which of course, you know, but it's silly because right now mine says alpha, as in alpha has been touched, and that's alpha. So I'm just going to untouch alpha and then go second L1. So that might take a little bit of work, and if you have problems, let me know and we'll figure it out. So anyway, good to go. We can make it a little dot, we can make it a plus sign, we can make it a really tiny dot, I think. That dot's just fine. Great. Now, this is a part that we're going to have to do every time. So this is a really important part for us to figure out, and this is a really good little piece of information for us to keep in mind. We're going to have to set our window. And what I mean by set our window is we have to figure out how much of this picture do we want to see. Do we only want to see this tiny little square down here? Well, we could set our window to go from like 0 to 3 and 0 to 30. And if we do that, that's the picture that we would see, which is really not great. I want to see the whole thing. So I'm going to set my window settings so that the x values are from 0 to 6 and the y values are from 0 to 60, or even a little bit bigger than that. But at the very least, that's what I'm going to set it at. Now, I made this graph already, what we did, but I can see all that information from the chart. So when I make my window settings, I usually look at the chart to give me some clues as to how big my numbers should be. So let's go here and let's try and figure this out a little bit. First, we're going to hit this button window at the top. So no blue button this time, just straight up window. I had some other stuff in here. I think I was graphing something. And here's all the things that we're going to have to make choices about. So x min, that's going to be our smallest x value. And we're going to go a little bit smaller than it so we can see the whole picture so that nothing is cut off. In our example, the smallest day was 1, but let's even go to 0 or -1. And the weird thing about your calculator is it doesn't love this minus sign on the side, so you always have to use this little negative at the bottom when we're entering stuff in. So a little -1 perhaps. X max, that's our biggest x value. So we went up to 6 days. I might say, like, let's go up to 8, just so we see a little bit more, just so we make sure we see it. Now the scale is, what do you want to go up by? So we can go up by ones, because it's pretty reasonable to go from -1 to 8. If we're going from 0 to 1,000, I don't suggest you go up by ones because your calculator will take forever to graph that. So I suggest you go up by like 100s. You know, what would you want to like skip count by to get from -1 to 8? 1, fine. Okay, now y values. My smallest y value is 16. I like to throw in a 0 in there when I can, because that way we can find intercepts if we need to. And usually when I'm going to put a 0, I'd rather put a -1, just so that way nothing is cut off at all. My biggest y value was 52. Let's go up to like 70, just for fun. We can literally put in anything we want here. We can always come back and change it, so this is not set in stone by any means. And if I was skip counting from -1 to 70, I think I'd like to go up at like 10s, 15s, 20s, 5s. It doesn't matter. It's just it's kind of a guess. And then our x res, we can leave that. So great. Looks like it's time to maybe look at this thing. So I didn't put this in here, but the next button, we're going to use this a lot. To actually see it, we're going to hit graph. And I have something else in there, which we're going to erase in a second here, a beautiful graph. But I see all my dots. I can see all of them. I don't just see a few of them. I do see all of them, which is great. That's kind of what I'm looking for here. All right, now let's do the next part. So this next part is finding a line of best fit, and that's typically what we actually want to do. I don't just want to see a picture on my graph because that's not that helpful. So let's try and do that now. So find the regression equation. So this will actually give me an equation like y equals something, something, something. This is the one we're going to do right now. So let's find that stat button again. Stat. We go over to calc. I want that one, so I'm going to hit to the right button right there. And this is where we have a ton of options, like 15, 20, 15 options in there. The one we want right now is linear regression, ax plus b. You'll notice that there is a linreg a plus bx, just to be confusing, and we're not going to linreg, we're not going to use that. We're using the one number 4 ax plus b, and that's the form that I'm used to, so that's okay. And hit enter, or you can hit number 4, and it pops up like this. On my calculator, have to hit enter again. Your calculator, you might have to hit enter a few times, or just kind of cycle through that stuff. If you have problems, let me know, but this is what you should end up with after you hit enter. So I'm just going to write mine down here, because I already did this, so I don't have to do it again later. 6.89x plus plus 9.4. And we're going to use 2 decimal places for everything that we do. When in doubt, use more decimal places. You could use 3 or 4 if you really felt like you should. But we definitely want at least 2, or else I have to take marks off. So the 6.89 is the A part, or the M, and then the B, the y-intercept, is 9.4. So we say 6.89x plus 9.4, and we have a beautiful linear regression. Now, sometimes we want to graph it, because when we graph this line, we can actually find stuff off of it. So what you have to have is, you have to have this on your screen, so do not hit clear. I know people love to hit the clear, love to hit the clear button. I'm not super sure why, but do not hit the clear button. Let's graph this line. And I want to keep all the decimal points, because I don't have to write them all down to then be able to type them in. And I don't want to lose any of the decimal points, because then my answer will be beautiful and perfect and like as precise as it can be. So don't erase that. What we're going to do is we're going to copy and paste it into the place where we can graph lines. So let's follow these next steps here. Graph the linear regression equation. The steps will be the same if it's a quadratic equation. We'll just make a different choice right here. We won't do number 4 if that's the case. Okay, so this step will paste the regression equation into the y equals function in your calculator. So you have a precise equation, you don't have to copy everything down. Okay, so let's look at this y equals, and that is where we kind of make our little equations for our graphing calculator. So y equals. I have some random stuff in here, so I'm just going to clear and clear, so it gets rid of all that. You don't need that. You might have some different options selected over here, so I'm just hitting enter. We don't want all these weird things. We really just want a line. So if you have something else in there, go through and hit enter. If you have any of these selected, oh, well, there's nothing in there, so you can't hit enter yet. Okay, so this is the place that we're going to enter equations, and I want to copy and paste this equation from down here. So how we copy and paste is we're going to find vars, right here, vars. Okay, say 5 for statistics. Then we want EQ, so I have to go over to EQ. 1 for regression equation. 1, I almost hit 7. Okay, and you'll notice it pops in there with all the decimal places and the x in there, and we're good to go. I'd like to see this now, so let's hit graph. And it puts a beautiful regression equation through my line. It doesn't know that negative days doesn't really make sense, so that's okay. It's going to be in there, but we can make those decisions ourselves. Beautiful. So I graphed it. I determined the regression equation. Let's flip. Let's see what else we can do here. What is the slope? Well, the slope is the 6.89 part. Typically, we're going to put units on everything that we can, and slope is how steep this line is, right? So the steeper it is, the more hair she's losing. The flatter it is, the less hair she's losing. My girl's pretty sheddy, so she is on the, she's not that steep actually, but this is made up numbers. But let's put some units on that. So what I want to know is how my units go. It's usually the y-axis over the x-axis. So number of hairs lost over day. So I'm just going to say hairs lost, hairs per day. It represents how many hairs we losing. All right. What is the y-intercept? The y-intercept was 9.4, and that point is right here where we cross the y-axis. So that would be how many hairs did we lose at the beginning or at day 0? Hairs at the beginning. Alrighty. Now here's a bunch more things that we can find, so it's more just information for us for the future. Here are 3 ways to find some values, and these are just kind of like regular values. There's going to be some specific ones we'll find in the future, for example, maximum points or minimum points, and I'll show you how to do that later. But for right now, these are just kind of general points. So once you've graphed, you can find a particular point with some options. 3 options, one of 3 options. Option 1, option A. We can use this trace button. So up here it says trace. Let's hit that and let's see what happens. So right now, if I go to the right or left here, my little cursor bumps between all those points. I don't care about the points anymore. I want to look at the line of best fit. I don't want to look at the points anymore. So sometimes what I even do is I go back to my stat plot. So second stat plot, and I might turn that stat plot off. Another way you can do it is just go to y equals and go to the top there and either highlight or unhighlight it. And that turns off those dots because I don't really like to see them, and I want to make sure that I'm not getting values off of the dots. I want to get values off of the line instead. So going back to what we're actually working on here, trace. When I go to left and right now, I go up and down the line. If I still had the points on there, I can hit up or down and it will get me onto the line. But let's go to the left and right, and this will find us millions of points, but they're all kind of weird decimal numbers. So if I just need an idea of what the values are, I can go left and right and it'll give me a good idea. So it's good for giving you a general idea what the values are, but it's not great for specific values. Enter option B. Here's a really good way that we're going to do a lot of. It's good for finding specific y values when you're given an x value. So let's try that. Let's try it on down here actually. Yeah, let's intro it. Okay, so we want to go to trace, but actually we want to use calc. So I'm going to say blue calc. And here's a bunch of options. We're going to use a lot of them actually, not these ones down here because that's for calculus, but this number 1 is the one we're going to use right now, but this is a good place that you need to be able to get to. We're going to say 1 for value or enter, and this is where you can put in an x value. So if I put in how many hairs would I have lost at 5.5 days, it will tell me with beautiful preciseness with all those decimal points. So when you have an x value, you can put it in and it will tell you the y value. Finding, if I have the y value and finding an x value, it's a little harder. So here is option C. So let's say I'm like, when will I have lost 50 hairs? And what day will that be? Well, that will be this option right here. So we go to y equals. Do not erase this because this is my information. We're going to go down to an unused line and we're going to enter our y value. So if it was 50 hairs that I wanted to know about, I would enter in 50. Go back to our graph and you'll notice there's a beautiful horizontal line here now. And where those two lines cross, that's going to be where there's 50 hairs. So what I want to do is I want to figure out where do these two lines cross. So it says, go back to this second trace thing. So we get calc right there. And we're looking for where do they intersect, which is 5. And then it says first curve, so I hit enter. Is that the second curve? Yeah, sure. Hit enter. Guess? Yeah, sure. Guess. So you really just hit enter 3 times. And it tells me the point there. It tells me when y is 50, x is 5.90. Alrighty. So let's try these ones real quick down here. And Penny is currently barking at someone. Great. Penny. And then we'll be done for today. Okay, so if you extend your graph, how many hairs will she have lost by the 10th day? So first things first, 10th day, is that an x value or a y value? I would say that's an x. So x equals 10. So we're going to be using option B to figure this out. And it specifically tells me I probably have to extend my graph because I only made it go up to 8 days. So right now, if I try to put in 10 days, it'll give me this error, which makes me feel like I'm doing something wrong. It's just that I don't have enough space to show what I'm doing on here. Like my calculator is saying, no, you only asked me to look for this information. So what I have to do is go back to my window. I want my x max to be at least 10. Let's make it even 12, just for fun. And what I might have to do now is, this is kind of around, like 9 days maybe. I might have to go up a little bit further so I see a little bit more of the picture. So going back to my window, and this is where we're just going to have to play with our window a bit. Let's make our y max. Let's make it like 150, just so I don't have to do this again. So I'm just making it quite a bit bigger. just so I can see everything again. And now that I think x equals 10 is going to be on my picture, I think I can do option B. So second trace, 1 for value, x value is 10, and it tells me she will have lost 78.26 hairs. And it's okay to leave decimal points here. How many hairs will she have lost by the 25th day? I'm going to ask you to do that one on your own. Let's try this one. After how many days will Penny lose 200 hairs? So 200 hairs, is that an x value or a y value? I'd say y this time, which is why I wanted to do this one. And I want to know what the x value is. So we're looking at option C. Option C is definitely the most annoying option, but that's okay. So we're going to go y equals, I don't need this 50 in there anymore, but I do need a 200. So I want to know, when are we losing 200 hairs? Throw a 200 in there, graph it. Okay, it always takes a minute to graph my functions. And I can't even see that horizontal line. The reason is my window's not big enough. I didn't make it big enough. So I have to just adjust it a little bit more here. So my y max should be at least 200 now, because that's kind of what I'm talking about. Let's make it 220. And let's see what we get. Okay, I can see that horizontal line now, but they don't cross each other. And what I want to know is where they cross each other. So if I were to try and do, whoops, this option C kind of moves right now, it would give me an error. So I just need to see further to the right so I can see where these two things cross each other. So back to my window yet again. Let's make this way bigger. 25? Is that big enough? Let's see. Oh, maybe not quite. Oh god, no. Okay, not quite. A little bit more. 35. So it does take some playing with. I'm kind of only making educated guesses. I don't know for sure what it should be. And then let's follow option C here. So second trace, 5 for intersect, enter, enter, enter. There's my information. So we'll have 200 hairs by the 27.68 days. Alrighty, so that's it for today. Try the last one on your own there, please. Here are some homework questions for you. Give it a shot. Let's see how it goes, and have a good day.